Random numbers are essential in Monte Carlo simulations, cryptography, and computer science. But not all random numbers are the same. There are two main types: pseudo-random numbers and true random numbers. What are random numbers? A random number is an unpredictable value within a given range. In theory, each number should have an equal chance of being selected. Random numbers are used in simulations, statistical sampling, gaming, and even security encryption. But how do we generate random numbers? This is where we need to understand the difference between pseudo-random and true random numbers. What are pseudo-random numbers? Pseudo-random numbers are generated by algorithms. They appear random but are actually determined by an initial value called a seed. Since the process is mathematical, it can be repeated if you use the same seed. Computers use pseudo-random number generators to quickly generate sequences of numbers that look random. Some common PRNGs include linear congruential generators, one of the simplest and fastest methods. Mersenne twister, a widely used PRNG that generates high-quality sequences. XOR shift and PCG generators, more modern algorithms that improve randomness. PRNGs are deterministic, meaning if you know the seed, you can predict the entire sequence. This is why they are not suitable for cryptographic applications like password encryption. However, they are widely used in simulations, video games, and procedural content generation. What are true random numbers? True random numbers come from physical processes that are inherently unpredictable. These are generated using hardware random number generators, HRNGs, which rely on natural randomness from sources like thermal noise in electronic circuits, radioactive decay, quantum effects in photons. Because these numbers are based on real-world physical processes, they are non-deterministic and impossible to predict. That makes them ideal for cryptography, secure communications, and high-stakes simulations. Pseudo-random versus true random, which one to use? The choice between pseudo-random and true random numbers depends on the application. Monte Carlo simulations. Pseudo-random numbers work well because we need speed and large sequences. Gaming and computer graphics, PRNGs, are sufficient since perfect randomness is not necessary. Cryptography and security, true random numbers are essential for secure encryption keys. How Monte Carlo simulations use random numbers. Monte Carlo methods rely on random sampling to estimate probabilities and solve complex problems. Since simulations often require millions of random numbers, pseudo-random generators are used because they are fast and repeatable. For example, in financial modeling, we simulate different stock price movements by generating thousands of random price changes. If we use true random numbers, every simulation run would be different. But with pseudo-random numbers, we can reproduce results for verification. Conclusion: random numbers are at the heart of Monte Carlo simulations and many other fields. While pseudo-random numbers are fast and predictable, true random numbers provide the highest level of unpredictability. Understanding when to use each type ensures we make the right choice for different applications.